Welcome to FAANG tastic solution. So today we'll be solving a Leetcode medium problem named as number of enclaves. So let's go through the problem and then try to see what we can do here. It says given an m cross n binary matrix grid. So we'll be given a grid here where 0 represents the C cell. So whatever the 0 we have, that is the C cell, and 1 represents the land. Now it says a move consisting of walking from one land to another adjacent land, walking of the boundary grid. So a move consists of walking from one land to another adjacent land cell or walking of the boundary grid. So what do we mean by that? Let's say if we are at any particular land, so move like we can move to any other land, or if you're here, then this is basically a boundary grid, right? So we need to return the cell number of land cell in the grid for which we cannot walk off the boundary of the grid in any number of moves. So whatever the land we have, the only way the valid moves are, we can move in any direction. If I'm here, I can move in any direction. But the valid moves are only on the land. So I cannot move onto the water. So this is invalid move. This is invalid. This is again invalid. So out of these four, only this one was a valid. From here again, we know this is a valid move. But again, this is a locked, like we cannot move, outside this grid. Like we are unable to reach to this, the outer layer of the grid. So here we need to return the number of cell in grid for which we cannot walk off the boundary. So here the total output is 3 because out of these 3 land cells, we cannot, move out of the grid. But this one grid, we can definitely, go outside the grid because it's onto the outer layer. But what if we had 1 here instead of 0? Let's say if we had 1 here, what could have been the output for us? During that, if we had a 1 here as well, then the total number of output would be 0 because from each cell, where we have the 1, we could move outside, the grid. So let's say if we were at here, our valid move was this left was a valid move. Then again, this was a valid move, and then we could have gone outside. Similarly, from here up, right, and then right. From here, either we can go up or right, left, then here left, and then here left and outside. But in this given current example, we know that we are only going to get like from this one only, like we're going outside, but the rest 3 are basically locked, the grid, locked, basically locked by the water. So if you see, these are the locked by water, we cannot go outside the grid. So we need to return the total number of grid which are basically into the locked by the waters from all the sides. That's what we need to return. So let's go ahead and try to see how we can solve it. So this would be one valid example again, where, if you see, we are this at the outer grid right here. And if we try to, let's say, move from here, can we move outside the grid? So yes, we can go right, up, and then outside. If we are at this point, then we can go up and then again up. If you are at here, then again up. So these 3 like won't be counted for us. But what about these 2? From here only valid move is right. From here only valid move is left, but we are still inside the grid. So the total count would be 2 here for us in this particular scenario. So how do we do that? So one approach would be like, say, start from the end and like whenever you encounter 1 and try to go outside. The one valid, the one more easier solution would be, let's say, we know that our end goal is to reach to this outer layer of grid, right? So the first row, or either into the last row or the last column, right? Or the first column. If you're able to reach at any of these places, then we know that, we can go outside of the grid. That's our end goal. So if you're any place inside this grid, if you're able to touch this first row or last row, first column or last column, right? So we know that we should be able to move out of the grid from that particular cell. So one of the valid scenario, like, or the easier scenario, why not do the same way? Like instead of going from inside to out, cannot we go from outside to inner side? Like from all the 4 corners, right? From the first row, last row, or first column and last column, and see if we find any one at any place, right? Then go ahead and try to find all the connected ones and see, just discard those ones. Like we don't need to count those ones, right? So in this particular scenario, let's say if you're starting from this last row, right? So we'll be reading all the values are zero, or if you're, so either we can go from down, left, top, or bottom, right? So these are the four valid things. Like we need to go one by one from all the four direction, and the moment we find one at any of the place, outer place, right? Then what our goal should be, try to go ahead and find all the connected ones from this particular cell in any of the direction. Like say if we found here or here, at any place, we find one, just go ahead and just go ahead and try to find all the connected cells into the one. In that scenario, now we know that from all the four corners we have covered all the ones, and if there is something which is remaining, then those ones can't be reached to the outer layer. So what do we mean by that? So either we can do the DFS or VFS, but I'll be following the DFS function. So let's write some function. What the goal of this function should be? We'll be calling this function from all the four directions, and from each direction one by one, right? The moment we find any one at any particular place, the goal of this function should be to just go ahead and mark all the connected cells. Mark all cells with some value. Either we can mark with 0, right, or some other character has, or something else, right? So that we know that we have visited those particular ones from each direction one by one. And then so that would be the first, like the number one step should be from all the four direction, call one of our function DFS. And this DFS function, what it will do, it will just go ahead and mark all the cells, all the connected cells which has the value 1. That's the end goal of this, the DFS function would be. And second time we can again iterate through this grid one by one and find all the ones, count of all the ones which are not marked, right? And then return this particular count. So let's try to solve this particular scenario. So let's say if you're going from this bottom side, right? So we can see we are going to read this and everything is 0. So this function won't go ahead and mark any particular cell. But from the left hand side, again, we'll see there is nothing, no 0. And from the right hand side, again, it will go and see there is no 1. Sorry, when I mentioned here 0, it was basically what, there is no 1. So these three side, this TFS function won't do anything. But what about from the top? If you're going to call from the top, it will go one by one. And then the moment it will find 1, our goal should be again to, visit in all the four direction, move in all the four direction, and see if we have at any place 1. So it will go first, it will mark like it's kind of a visited set or visited or something like that, and then move in all direction. So this TFS function, what it will do, first it will mark and then move in other directions. So explore other directions. That's what it's going to do. First it's marked, and then this is an outer condition, right? So we can't go outside, and this is again a 0, right? So we can ignore this. This is again a 0, we can ignore this. And then down we again got 1, right? So now since we again got a 1, we'll be again calling our DFS function here, which will again go and mark this with some tag. Let's say we can choose either 0 or has something, right? And then it will again try to move in all the directions to explore this. And this was already visited, then we don't need to visit there. And here we got 1. So again, this will come and mark this and try to visit in all four the directions. This was already visited, so we don't need to visit it because it's already marked as visited. So none of them are, other things are which is 1. So we are good with this DFS function. So what we did, you can say recursively we called our DFS function one by one, and it goes ahead and mark these all three ones. And this was the end. And now again, in the second iteration, what we'll do, we will just go and iterate, check each node one by one, and if it is 1 and not marked, then only we need to increase our count. So here we, even though we found 1, but it was marked with some whatever the visited set we have done, so we won't be increasing the count. Similarly, in the second row, we won't be increasing the count. Here everything is 0. Here we came here, we can see again 1, but it's not marked as well, right? Not visited set. So we'll be increasing count by +1 for the first one, the second one again by +1. So that's why answer would be 2. So these two cells are basically, the locked inside this particular grid. So that's the approach to solve this problem. Now let's quickly try to write the program for this, which will make it a lot clear now. So as we said, we are going to, in the very first one, what we are going to do, we are going to explore from all the 4 directions, right? That's our end goal. So let's start reading the cell one by one. I plus plus for let j equals to 0, j is less than grid of I dot length, j plus plus. And now when we are into the first row, right? So one should be the first row, last row, first column, and last column, right? These are the 4 scenarios when we have to call one of our DFS function. So we'll be calling on our DFS function. We can pass, the index I comma j. And what this function should do, this should go ahead and mark all connected ones and nothing else. It shouldn't return or do anything. It's the only purpose of this DFS is to go ahead and mark all the connected ones from these outer layer. Okay. So we need to call this DFS function 4 times, one from this first row, second from the last column, last row, last column, and the first column. So for the first column, the condition should be if I equals to 0 and grid of I comma j equals to 1, right? If that is the condition, then just go ahead and call our DFS function with I comma j, right? So what we are just assuming, then when we are going to write this function, this will just go ahead and from the very first row, if it find any ones, it will just go ahead and mark all connected ones from this particular first row. Similarly, the last row should be if I equals to grid dot length -1 and grid of I comma j equals to 1. Or we can write grid of ij as well. That doesn't matter, right? But I'm just adding it. And again, call our DFS function from here as well. Just pass DFS of I comma j. Now, from the first column, let's just go and explore the first column. So the criteria of first column is if j equals to 0. So if j equals to 0, then we are into the first column, right? And grid of ij. Then call our DFS function. And then the last column. So this would be if j equals to grid of I dot length -1 and grid of I comma j equals to 1, right? So just go ahead and call the DFS again from here as well, I comma j. So now if you are done with this particular loop, then we know that we have just, marked everything 1, right? So whatever the remaining ones are there, we just need to go and explore like or traverse this grid again and find the none marked value, which are, the 1. So just go ahead and have the counter for them. So once we are done with this, let's initialize the counter equals to 0. And what we are going to do for marking this grid, currently, like for the very first time, what I will do, I'll just mark the connected one with 0 itself into the same grid. I'll update them. So that's the one thing. Or other way we could have marked with some other variables as well, or something like. So I'll just go ahead and mark all the connected ones from first row, last column of last row and first column with 0 only. So that should be our end goal here. So now the criteria should be again. Let's start traversing this array. Oh, sorry, grid. And now what our condition should be? If grid of I comma j equals to 1, so if we know that it's equal to 1 and we have not marked something like this, right? This particular cell, then only just go ahead and do count plus plus, right? That should be our goal. But what we are doing for marking, that particular cell, we are just initializing with 0 only currently. So if we find any 1 here, so I'll just explain. So what do I mean by that? So if here I have found something, let's say, hold on a second. So here, if we come here and if I find any 0 in the first row, right, I will just go ahead and update this with 0. Similarly, this one marking basically means I'm saying whatever we are going to mark for the first time, I'm just going and updating with the 0. This one will also be, I'm updating with the 0. That's what we are going to do currently. So it's just technically basically means, instead of marking some other thing, we are just going to update with the 0, right? So I can just remove this not marked condition, but just to let you know. And then once this is done, we can just go ahead and return this count. Cool. And now let's try to write our DFS function, what it will do. So in DFS, what are the things not allowed, right? Going outside this particular grid is not allowed. So what we can do, if I is less than 0 or I is greater than equals to grid dot length. Similarly, if j is less than 0 or j is greater than equal to grid of y dot length, then just go ahead, we can just return it. We don't need to return true or false, which is fine. So we are not allowed to go outside this boundary, right, at any time. And the second thing, if we are encountering any 0 only, then we can just return it, right? So if the grid value is 0, right? So if grid of I comma j equals to 0, in that scenario also we can just go ahead and return it. Now, after this particular line, if code is coming here, then we know that we have encountered a 1 at that particular cell. So what our goal should be, just go ahead and so this one we are good. From each direction we are calling our DFS function, and the moment we are encountering any 1, what we are doing, we are just going and mark with like some visited or something like that, and then move in all 4 directions. That's our only goal, is to do it here, right? So we are done with this part, and we are calling this DFS function in all the 4 directions. Inside DFS, now we are going to write, the moment you are finding any 1, first go ahead and mark with something else, and then explore in all the 4 directions. That's what our goal should be. So now this particular cell, I'm just going and marking with something else, which we decided currently, like we're just going and updating the same grid cell with the 0 directly, and then call the same DFS function in all the 4 directions, right? So I plus 1 comma j, I minus 1, or I comma j plus 1 and j minus 1. That's it. That should be our goal, and at the end of it, like, we can just return it. We don't need to return true or false. That should be our goal. So now if you're good with this, we should be able to have the proper count here. Now let's go ahead and try to submit this. It got accepted, and thus submit it. It's cool. So that's how it got accepted. So our goal was, every time, just to reiterate, explore this grid from all the 4 directions, call our DFS function. What it goes ahead and mark this grid with a visited set or something, visited values, and then explore again in all the 4 directions. That's what this DFS function will do. And after we are done with this DFS marking, then again go ahead and iterate this grid again, and whatever those values which are not marked with the 1, just go ahead and increase the count. That's what we did. Now let's say, so this was when you are marking with the 0, but now let's say if you want to mark with something else, right? Or if in the exam, or if in the interview, right, we are not allowed to change the existing grid, right? So what you can do, you can just create your own 2D grid if you're not allowed to alter this particular grid, right? So the logic would be same. What we will do, if we are not allowed to change the existing grid, we can just go ahead and create our own 2D grid. So how we can do it? Just first create a new, the visited array, which would be a 2D grid again for us. So this would be new array of grid dot length. And if I just want to initialize with something else, so I'll just go ahead and create 2D grid now. Visited error dot length comma I plus plus, and then visited array of I equals to new array of grid of I dot length, and let's just fill this with false, right? So like we just initialize a 2D grid with all the false values here. So we know that we haven't visited any of the cells. So like we just created again a 2D grid of the same, the m cross n, and each cell we have initialized with the false. So now our goal should be the moment we visit any particular cell, and while marking that visited, instead of changing the original grid, now we'll be changing into this visited array. That's what our goal should be. So now if we have done this, so what will be the change here? So the very first change would be here when we are going to mark this, visited. So we'll be marking visited ARR of I comma j with true, right? So anytime we are encountering this one, right, in outer cell, we are just going and marking, instead of changing our original grid, we are changing the visited array of that particular cell as a true. And that's the one change. And second would be while returning this false, right? So the criteria would be same. We can't go outside of the grid, and the grid particular cell shouldn't be the 0. And the second should be, it should also not be the visited set, right, into our visited array. Then also we need to return false. So if you have already visited this particular cell in the future, right, so what do we mean by that? Let's say if I came from here to here, and now our DFS, when it's going back, if I have already marked this as a visited, we shouldn't go ahead, and again call the DFS from this particular place as well. We should return false, which element has already been marked there. So we just need to check this one as well. If visited array of I comma j, so this particular cell has been marked with a true, then also just return it. So that should be the criteria into the DFS. And while this increasing the count, now other condition can be added here. If the particular grid in its original grid is, the cell is 1 and it's not visited, right? So visited array of I comma j. So if it's not visited, so we can just return this not. If that's the condition, then only increase the count. So now what we are doing, we have just created our own 2D grid, and instead of changing to the original grid, uh, we are calling this DFS at any particular time. We are finding the one into this outer layer. So what we are doing, we are just going and initializing or visited array of that particular cell with the true, right? And just exploring in all the direction. And if you're finding any at any place, one, let's say if, into this grid, we are just going ahead and marking our visited cell with the true. That's what. And we don't want to revisit the same cell, which we have already come from. So that's why in this returning false, we are just adding this condition as well. Like if it shouldn't be the visited array. And into the second program, when we are going to count this once, right? So we are making sure even if this value is 1 into the original grid, it shouldn't be visited, right? So that's why we are checking the condition that if the value of grid comma I comma j equals to 1, and if it's not visited, then only go ahead and increase the count. So that's the proper way to do it. So if we are allowed to change the original grid, then we can just go ahead and mark it 0. We don't need to add the condition of this visited array or something like that. But if you're not allowed, we need to create our own 2D array or something like that. Now let's go ahead and run this. Accepted. Let's just submit it. cool. So this got accepted. So if you talk about the time complexity and space complexity, time complexity would be big O of n cross m of this particular grid, and space, if since we're using the extra space, which is b n cross m. That's it for today.